still give us some useful information. And so we test people behind the scenes. So everybody gets an accuracy level, and that individual accuracy level is used to weight their answers. So if you're very good at classifying hard coral, your answers count more than, say, my answers do. And so we can use the maths and stats behind the scenes to combine all these data and get an overall estimate of coral cover. Because we're not just asking one person at home to classify an image, we're asking lots of people to classify an image. And what we're betting on is that as more and more people classify the image, that'll converge to what that true value is.
Okay. So the project really got a boost this year when ABC Science picked it as the National Science Week Citizen Science Project of the Year. What kind of boost did you get? Can you talk about the numbers that you've gotten?
Yeah, that was quite exciting and unexpected, but we worked closely with ABC Science, and they promoted the project, and in the first month we got about 105,000 images classified by more than 5,000 people. So I think that shows that people at home they want to help and they're willing to help, but we just have to give them an opportunity to help.
And it really doesn't take much effort at all to classify an image. Just, a minute or two? Or what?
Probably less than a minute. It depends on how careful you are. But definitely around a minute, you can do as many or as few as you want. So yeah, I would encourage everyone to have a look and help us classify images. The other exciting thing is you get to see what real reefs look like all along the Great Barrier Reef.
A project like this, isn't this better for helping the reef because it involves such a big community from around Australia and maybe even the world that people might buy into it more? Is that your hope?
Well, it is our hope. We've talked a lot about people at home, but this is actually a collaboration across multiple organizations. So University of Queensland, Reef Check Australia, Australian Institute of Marine Science. So I saw an estimate the other day that said there were 90 different organizations monitoring either on the reef or in the reef catchments. And that's a lot of effort, a lot of fragmented effort. And so what we're hoping that by encouraging people to take images, image is sort of a common currency, and we can combine those images across those different organizations. And so all of a sudden we're pooling all of our efforts, which gives us a lot more spatial and temporal data across the reef.
When we talk about images, there's a truth behind these images, isn't there, as opposed to maybe multiple divers looking at the same thing, and you might get different perspectives based on who's seen it. Can you talk a little bit about that? Yeah,
absolutely. Studies have shown that when someone visually estimates coral cover and other characteristics, there can be a lot of variability, even when you have marine scientists doing it. So when we take images, there is that underlying truth that you can always come back to. The other thing is that who knows what else we could learn from these images. These are data that we can save, and in 10 years' time, we might analyze these images for another reason. So it's hard data, it has an underlying truth, and it's there for future generations to analyze.
And the data you're getting from the citizen science part of this, are you combining that with other forms of data?
We are. So we're combining that with the professional monitoring data right now just from AIMS and two groups at the University of Queensland, the Remote Sensing Research Center and the Global Change Institute. But and also from Reef Check Australia. But even with that small number of organizations, we have over 100,000 images from them. So you can imagine if we were working with all of the organizations monitoring on the reef, that'd be a really rich data source, especially when you combine it with reef operators and tourists.
I'm talking with Dr. Erin Peterson, the project leader for Virtual Reef Diver. Erin, let's talk more about that. Now, you recently launched the next phase of the project, which is to get the diving community and tourists involved in providing more images, new images. That's a big step.
Absolutely, because, as if we can get reef operators, tourists, and even some of the other monitoring groups out collecting data, that's data in new locations where we didn't have any information before, so that people can come online. You have to register. And then upload images, and we within 2 to 3 days, those will show up on our website, and other people at home can help us classify those images. So that's really important because things change on the reef very rapidly in space and time. So you can imagine cyclones come through. We could have crown of thorns starfish outbreaks. There can be other damage to the reef, and so essentially, this is an army of people out helping us monitor the reef so we can do it cost effectively and we can do it better.
Now, you've talked about creating a virtual map of the reef, and clearly you don't have images from every part of the reef just because it's so big and it's so spread out. How do you get an accurate picture of the reef if you only have pictures from X number of spots?
Well, we use maths and stats to do that. So we have models that we fit to those observations that people are giving us on the ground, and we use those models to make predictions in areas where we didn't sample. And so that's why it's so important to get data in new places, because the more data we have that's spread out over the reef, the better our model predictions.
And by predictions, you mean predicting what's happening now in spots where you are not. Is that correct?
Yeah, well, there's lots of different uses for scientific models, and that's one of them. So that's one of the main things we're doing now, is trying to use those models that are fit to our observations and predict, to the best of our knowledge, what's going on in those areas where we didn't get to sample. But, scientific models could be used to run scenarios. So what do we expect to happen if we get a 2-degree increase in water temperature? Or how do we expect the reef to respond if a cyclone comes through this area next year? Or if we close a particular area off for fishing, do we expect to see a coral recovery, and at what rate? So there's scientific models, and those maths and stats play a really critical role when it comes to monitoring and managing the reef.
And we're talking about spots that are both declining and improving in health, right? Because you don't hear a lot about spots that may be improving, but there is kind of both going on, maybe at different levels. Is that right?
Yeah, absolutely. I mean, that's the thing about the reef that's so neat, is that it's a very dynamic system. So it evolved to respond to disturbances like cyclones and floods. And so we do have areas that, may have been hit by a cyclone that are recovering. But overall, I think that it would be fair to say that in most areas on the reef are declining.
As the ASIMS communications person, I've had to learn a lot about maths and stats because my background isn't in maths and stats, and I hear people talking about models all the time. And really, I had to start thinking about models as like people building things. And, you build a model, and it really is a representation of what's happening or what something is. And so when I was able to get my head around that helped me talk a little bit about statistical modeling, mathematical modeling. It's just when it comes to what you're doing, Erin, really what you're building your models with is with data, right?
Yeah, well, all the modeling that I do is data-driven. So, the first step in the thought process is to really understand the problem. And so that's where my background in sort of environmental science comes in. So if I'm working on something like coral cover, I start to think about, well, what are the things that can affect it? So I know that water temperature is important. I know that cyclones are important, crown of thorns starfish, things like that. And so then I go look for other data. Do I have information about how sea surface temperature is changing through time? And so I sort of build a conceptual model about what affects it. Now, some things I know are important and we can measure, and so we can put those in our model. But there's other things I know are important, but we can't measure. And then, of course, there's the things that are important that you don't know about. And so really, we're building a conceptual model or conceptual framework of how this system works. It's overly simplified, but we're trying to capture each of those different aspects and understand how coral cover is changing.
And if I understand this correctly, then it kind of builds upon itself, right? As you learn more about another factor or this factor, you're able then to add it to what you already have and improve the model. Is that right?
Yeah, absolutely. So that's the beauty of statistical modeling. The more data